Hi everyone and welcome to my YouTube channel. I am Ruzbeshad. This is the third part of the series on how to develop a software application. As you remember, in the first part, we did reverse engineering the Northwind database and created the data access layer. In the second part, I explained the multi-layered software architecture, and based on that, we created new layers such as the application and presentation layers and added them to the solution. In this part, I'll show you how to develop the model project, which is the basis of the software application and is referenced and consumed by other projects in the solution. If you haven't watched the previous videos of this series, I would recommend you to do so before following this part because they are prerequisites of this video. So, are you ready? Let's get this show on the road. Let's start by running Visual Studio and opening the Northwind solution. Expand the Northwind.models project and delete class 1. This project will contain both domain entities and view model classes, so let's first create a folder named domain to contain all domain classes. Some developers are accustomed to naming this folder entities, but I chose to name it domain to emphasize that it contains domain entities. We could create another folder named entities inside the domain folder and put our domain classes in it, but I'd rather avoid long namespaces in the application. Now you need to move all entities from the data access layer project to the models project. To this end, go to the Northwind.data project, expand it and select all classes except the Northwind context class. Cut the selection and paste them to the domain folder of the Northwind.models project. The next step is to modify the namespace of classes to conform the models project. You can do that quickly by using the find and replace functionality of the editor in the current project. After renaming namespace for all classes, save the changes by clicking the Save All button on the toolbar and leave the classes open for later changes. The reason for separating domain entities from the data project is that they are referenced by almost all projects in the solution, but not all projects necessarily need to have a reference to the data project. Now go back to the data access layer project and open the Northwind context class. You'll notice that the entity classes like category are underlined with a wavy red line that indicates they are undefined or unknown in this project. Add a reference to the models project. Then, using the Quick Actions menu, add the required namespace to the top of class file to correct the issue. Save all files and build the solution to make sure everything is okay. Another thing you may notice is that in the onModel creating method, all of the hasIndex methods on entities are marked as warnings with a wavy green line underneath. This is because we created the data access layer using .NET Core 3.1 and then upgraded it to .NET version 5. The hasName method used in .NET Core 3.1 is now obsolete in .NET 5. This is just a warning and not a serious problem, and it still works. But if you don't like the warning, you can remove it in two ways. Either replace the hasName method with the hasDatabaseName method as suggested in the warning message, or add the table index name as the second parameter of the hasIndex method. I'd prefer the first approach, so now it's time to make some improvements to our domain models. So go back to the models project and create a code file named state in the domain folder. Update the code file content with the following code. As you see, this is very similar to the entity state enumeration defined in EF Core. We'll use this enum to easily determine the entity state at the time of updating the database so that we can decide what operation to perform. Then, create a new folder named base in the domain folder. Create a class named entity base in the base folder. Add public abstract modifier to the definition of class. As we are not going to create an instance of this class and only want to use it as the base class for our domain entities. Create an ID property of type int. By convention, this will be configured as the primary key of entities. Also add another property named state of type state, which we already defined. Now let's add a protected constructor that initializes the state property to the unchanged value. This could be useful when you get a list of entities from the database using EF Core and you want they all to be initialized with an unchanged value as their initial state. We are going to use the entity base class as the base class for our domain entities. So let's start with one of the classes, for example the category class, and modify it so that it derives from the entity base class. To this end, use this notation. The reason we are making this change is that we can encapsulate many features in the base class and share them among the derived classes without duplicating code. This is one of the object-oriented programming principles. You'll also see in the future videos that this change makes things much easier when we'll create and use repository and unit of work patterns. To see what effect this change will have on the database, let's create a test migration by issuing the following command. By looking at the code in the test migration class, you'll notice that it's going to add the ID and the state columns to the category table schema. I need to remind you of an important point here. Because we started by reverse engineering an existing database, there could probably be an existing application that would work with this database. Therefore, you should be careful not to make changes to the database that would cause the existing program to crash. Changes to the database should occur only when the new application has developed and got stable. Hence, I'm not going to make any changes to the database at this time. Alright, let's first remove the test migration, so issue the following command at the PMC prompt. Second, decorate the state property of the entity base class with the not mapped attribute. It will exclude the state property from the database mapping. Third, you need to remove the category ID property from the category class and instead map the inherited ID property to the category ID column of the category table in the database. This is not straightforward by using data annotations, but can be done very easily by the Fluent API. To this end, let's go to the Northwind context class in the data project. Go to the onModel creating method and find the code that is used for configuring the category entity. Add the following statement to this part of method. Now modify all the remaining classes so that they derive from the entity base class. With the exception of the customer and order detail classes, remove the entity ID property from each one. And map the inherited ID property to the appropriate column of the corresponding table, like what we did for the category class. For the shipper class, there's no Fluent API code to configure it, so I borrowed code from another entity and made changes to it to fit for this class. You may notice that there's something wrong with the inherited ID property for most of the classes. This is because I forgot to add the namespace of the base class to the entity classes, so let's fix the problem. The situation is different for the customer and order detail entities. If you go to the customer class and have a look at the code in it, you'll see that the customer ID is of type string and different from integer. So we cannot replace it with or map it to the inherited ID property. Now let's have a look at the order detail class. You'll see that it has a composite key consisting of two properties, order ID and product ID. Again, we cannot map it to the inherited ID property. For each of these two classes, we could change the primary key to an alternate key and introduce the inherited ID property as the new primary key, but this needs a number of changes in the database schema. And as I mentioned before, I'm not going to do that at this moment. So for these two classes, we'll keep their primary keys unchanged, but we need a way to prevent updating customers and order details tables with the inherited ID property. We can do that using Fluent API, so let's go to the onModel creating method of the Northwind context class one more time. And add the following statement for the customer and order detail entities. Okay, before concluding this video, I'd like to do a couple of more jobs with our model classes. Let's go back to the entity base class and add the following method. This is a generic method that accepts a type parameter named t, which is of type entity base, with the new constraint. So, in our example, t can be replaced with domain classes like category, product, and so on. This method is actually a kind of factoring method that simplifies creating domain classes and can be a substitution for the constructor method. Now let's add some more methods and properties. As you see, the first method will be used for self-validation. Validation is automatic in ASP.NET Web applications and Web APIs, but there are situations you may want to do validation by yourself. Self-validation is also useful when using frameworks other than ASP.NET. Yet we haven't implemented it, and I'll show you how to do that at the right time. The last property will be used for handling concurrency conflicts, and the remaining properties can be used to track information such as the date and time of creation or modification. They are currently commented out because I don't want to make any changes to the database schema, and I just want to give you the idea of what we can do with the base class. Now let's go to one of the domain classes, for example category. To make it more readable, put the cursor at the end of each method or property and press the enter key to create a blank line between them. You can now create a non-generic version of the create instance method of the base class this way. I'd also like to rename the category name property to name, because when referring this property, it's more natural to say category.name instead of saying category.category_name. For this change, you should take care of mapping the new property with the correct column name in the category table. One similar change could be renaming the customer ID property in the customer class to code. That is, instead of using customer.customerID, we can say customer.code. You better do similar changes to the other classes on your own as a practice. One thing that I'd like to point to is that sometimes there are classes which have a lot of members, including navigation properties, and they can lead us to messy code. For such classes, you can separate navigation properties from other properties by creating a base class and move the other properties to it. This makes our code much cleaner and more readable. At the end, by creating a test migration, make sure the changes we've made so far has no effects on the database. I'll leave it to you as a practice too. There are still things we can do with our model classes, and I'll either create another video on this or explain it alongside other topics in future videos. That's all for now. If you have any questions regarding the content of the videos, I'd be happy to discuss it with you in the comment sections. If you've enjoyed this video, please do not forget to give it a thumbs up and also subscribe. Thanks for watching. I'll see you in the next video soon.